Welcome back to the AI Daily Brief. Today we're cutting through one of the biggest AI narratives of the week, the release of Kimmy K2 thinking model known as the open source model and the claim that Chinese AI has somehow leapfrogged American models. But as someone who's been testing these models daily, building workflows with them, and watching this space obsessively, I need to tell you, the story you're hearing isn't the full picture. Let me take you back to January and the DeepSeek moment, because understanding what actually happened then is critical to understanding what's happening now. When DeepSeek R1 dropped, the tech world went into a frenzy. Stock prices fell. Headlines screamed about China catching up. But here's what I noticed in my own testing that week, something that didn't make the headlines. I ran DeepSeek R1 against GPT-4 and Claude on a series of real-world tasks, complex data analysis, multi-step reasoning problems, and creative writing with specific constraints. And you know what? DeepSeek was impressive on the benchmarks it was trained for, but it fell apart on edge cases. When I asked it to maintain context across a 20-message conversation while switching between technical analysis and creative ideation, it lost the thread. GPT-4 didn't. This is what Ethan Mollick from Wharton, one of the most respected voices in practical AI application, has consistently pointed out: benchmark performance and real-world utility have a shockingly loose correlation. In his Substack, One Useful Thing, he's documented dozens of cases where models that score lower on MMLU or HumanEval actually perform better on the messy, ambiguous tasks that define real work. The narrative that DeepSeek proved China had caught up was always more about geopolitics than technology. According to analysis from Stanford's HAI, Human-Centered AI Institute, in their 2024 AI Index report, US-based organizations still published 3.2 times more AI research papers in top-tier conferences than Chinese institutions, and held 68% of the citations in breakthrough AI papers. The gap isn't closing, it's just being marketed differently. Now, about those training costs. Remember when everyone said DeepSeek achieved comparable results for a fraction of OpenAI's budget? SemiAnalysis, the leading semiconductor and AI infrastructure analysis firm, published a deep dive in February that completely dismantled this claim. They showed that when you account for subsidized electricity costs in China, industrial rates as low as 4 cents per kilowatt-hour versus 15 to 30 cents per kilowatt-hour in the US, government-sponsored compute access, and the actual performance normalized costs, the efficiency advantage, shrank to less than 15%. Here's the kicker: Dylan Patel from SemiAnalysis also revealed that Chinese labs often use older, less efficient H100 equivalents with higher power consumption per flop. The real innovation wasn't in efficiency, it was in aggressive cost subsidization that US companies couldn't match even if they wanted to. And yes, DeepSeek topped the App Store briefly. But according to Data.ai Analytics, within 30 days, ChatGPT had regained the lead, and DeepSeek's daily active users had dropped by 67%. Retention tells the real story. People try free things. They stay with things that work. Fast forward to now. Jensen Huang's comments about China potentially winning the AI race made waves, but let's read what he actually said in context. Speaking at an investor meeting in November, he noted China's strategic focus and coordinated industrial policy, which is real. But in the same breath, he emphasized that NVIDIA's most advanced chips remain US exclusive, and that's the most important advantage in the entire AI stack. I've spoken with data center architects, people who actually design these facilities, and they'll tell you something the headline writers miss: it's not about the number of data centers, it's about what's inside them. A recent report from Omdia, the tech infrastructure research firm, found that US data centers house approximately 85% of the world's H100 and H200 GPUs. China's facilities, by contrast, are largely running on A100s, older architectures, and domestic alternatives that perform 40 to 60% slower on transformer workloads. Gordon Johnson's viral tweet about China having only 449 data centers was based on outdated cloud scene data that only counts publicly listed facilities. But here's what matters more: the US has 12 of the top 15 AI supercomputing clusters globally, according to Top 500's November 2024 rankings. China has impressive compute, but it's distributed and primarily running inference, not training frontier models. So let's talk about Kimmy K2, because I've spent the last 4 days actually using it, not just reading about it. Moonshot released it with spectacular benchmark claims, 51% on humanities last exam, leading on BrowseComp and SEAL0, competitive on SWE Bench. I'll tell you what I found. On structured reasoning tasks with clear parameters, Kimmy K2 is genuinely excellent. I gave it a complex logic puzzle involving scheduling constraints, resource allocation, and optimization, it nailed it. Faster than GPT-5, actually. But then I threw it something messier. I asked it to analyze a business strategy document, extract the implicit assumptions, critique them from multiple stakeholder perspectives, and suggest alternatives while maintaining the original author's tone. This is the kind of thing I do daily with Claude and GPT-5. Kimmy K2's response was adequate. It got the surface-level analysis right but missed the subtle contradictions. It couldn't hold all the different perspectives in tension. It felt like a very smart undergraduate versus a seasoned consultant. Simon Willison, the creator of Dataset and one of the most rigorous AI testers I know, ran his own evaluation suite on Kimmy K2 and published results on his blog. His finding? Impressive on tasks with clear success criteria, unreliable on tasks requiring judgment. That's the pattern. Now, about those benchmark scores. Humanities last exam sounds impressive, but as Arvind Narayanan from Princeton Center for Information Technology Policy has pointed out, these general knowledge benchmarks increasingly test memorization more than reasoning. Models can be specifically trained on similar question patterns. What matters more are benchmarks like Simple QA, Google's Factual Accuracy Test, and Real-World QA, where GPT-5 still leads by 12 to 18 percentage points according to independent testing from LMSYS. The claim about 200 to 300 sequential tool calls is technically true, but here's what Moonshot doesn't tell you: error propagation. I tested this with a workflow that involved web search, data extraction, analysis, and report generation. By tool call 150, Kimmy K2 was hallucinating API responses and inserting fabricated data. GPT-5, which maxes out around 100 to 120 tool calls per session, failed more gracefully. It asked for clarification rather than making things up. Anthropic's Claude, in their recent system card documentation, explicitly addresses this. They intentionally limit tool call chains not because they can't go longer, but because reliability degrades exponentially beyond certain thresholds. It's like the difference between a bridge that can theoretically hold 100 tons versus one rated for 100 tons with a safety factor built in. Artificial analysis did rank Kimmy ahead on agentic tool use in controlled testing. But I reached out to Dimitri Martin from LangChain, the most widely used agentic framework, and he told me something illuminating. In production environments, we see 3x more error handling needed for Kimmy versus GPT-5 or Claude. It's fast and cheap until something goes wrong, then debugging is hell. This matters because enterprise AI isn't about demos. It's about what happens when you run 10,000 queries a day for 6 months. According to a recent survey from Gartner, 68% of enterprises cite reliability and consistency as their top criteria for AI selection, above both performance and cost. Some are saying this will delay GPT 5.1, Gemini 3, and Opus 4.5 releases. Having covered AI launches extensively, I can tell you, these models are developed on 18 to 24-month cycles that have nothing to do with reacting to competitors. OpenAI's roadmap was set in early 2024. Anthropic's training runs for Opus 4 started in March 2025. These aren't products that get delayed because a competitor had a good launch, they're massive research projects with their own timelines. What's actually happening is that Western labs are focused on something different. Sam Altman recently said in an interview with Lex Fridman, "We're not trying to win benchmarks anymore. We're trying to build AI that can do economically valuable work reliably." That's a fundamentally different goal. Let me show you what I mean. I built a productivity workflow using GPT-5 through the API that handles my research, drafts newsletters, manages my task list, and does data analysis. It's been running for 2 months with 99.2% uptime and 0 hallucinations that made it to production. I have validation layers, but still. The system is boring, reliable, and makes me 40% more productive. I tried replicating it with Kimmy K2. The cost savings were real, about $140 per month cheaper. But over 3 weeks, I spent 8 hours debugging edge cases, rewriting prompts, and implementing workarounds. My time costs more than $140. This is what Catherine Boyle from A16Z means when she talks about the infrastructure moat. In her 2025 AI investment thesis, she wrote, "The real defensibility in AI isn't model performance, it's the ecosystem of tools, integrations, monitoring, and support that makes AI deployable." OpenAI has partnerships with Microsoft, Salesforce, and every major enterprise software vendor. Anthropic has integrations with Slack, Notion, and Zoom. Kimmy has a Python library and good documentation. Now, let's talk about the open source angle, because this is where things get genuinely interesting. Pietro Scirato's novel writing agent and Lexi's egg balancing test were legitimately cool demonstrations. Open source is powerful precisely because it enables this kind of rapid experimentation. But here's what Devin Zugel from GitHub told me when I asked her about this: open source models are incredible for exploration. But 87% of our enterprise GitHub Copilot customers use closed models because they need the consistency, the security guarantees, and the liability coverage. That liability point is huge. When GPT-5 writes code that breaks something in production, OpenAI's enterprise agreement includes liability provisions. When an open-source model does the same, you're on your own. For a Fortune 500 company, that risk calculation is straightforward. The coding comparison is where this gets most interesting to me personally. I use Claude for about 70% of my coding, Cursor, which uses GPT-5, for 20%, and experiment with others for the remaining 10%. Kimmy K2 is genuinely competitive at writing Python functions and debugging syntax errors. But when I needed to understand a complex code base, maintain architectural consistency across modules, and suggest refactoring that improves performance without breaking existing functionality, Claude and GPT-5 are in a different league. SWIX, Sean Wang, one of the smartest observers of AI coding tools, recently wrote on latent space. The difference between good and great AI coding isn't in writing new code, it's in understanding existing code. That contextual understanding is where Western models maintain their clearest advantage. The Information's article about this being a crisis for Anthropic is, frankly, overblown. Yes, Chinese models are competitive on cost per token for basic API tasks. But Anthropic's revenue isn't primarily from price-sensitive startups, it's from enterprises paying premium prices for Claude Pro and Enterprise Claude, where the value proposition includes trust, safety, and Claude's constitutional AI approach. According to Anthropic's usage statistics, shared in their recent funding round materials, enterprise customers use Claude for an average of 3.8 different use cases, compared to 1.4 for open-source alternatives. That stickiness comes from reliability, not benchmarks. The point about Chinese AI companies needing international customers is actually the most revealing part of this whole story. As reported by The Information and confirmed by venture investors I've spoken with, Chinese AI startups face intense pricing pressure domestically because businesses there are reluctant to pay for AI subscriptions. That's not a sign of strength, that's a sign that the market closest to these products doesn't value them enough to sustain the companies. When you have to go abroad and compete on price because your home market won't pay premium prices, that's called distress exporting. It's what happened with Chinese solar panels, amazing technology, brutal economics that destroyed industry profitability. Now, the self-hosted LLM narrative is worth unpacking because it contains a kernel of real truth wrapped in a lot of hype. Yes, quantization techniques have improved dramatically. Models like Kimmy K2 can run on high-end consumer hardware with acceptable performance degradation. I've tested running Llama 370B on an M3 Ultra Mac, and it's remarkably capable. But here's what every developer I know who's tried this discovers: local models are amazing until you need to scale, update, or collaborate. Your laptop can run the model. Can it serve 50 concurrent users? Can it be updated in real time when the model improves? Can 5 team members access the same model with shared memory? Eugene Yen, who leads ML at Amazon and writes extensively about production ML systems, put it perfectly. Self-hosted LLMs are like self-hosted email servers, technically impressive, occasionally useful, almost never the right choice unless you have very specific requirements. The use cases where local LLMs make sense are real but narrow: medical applications with strict privacy requirements, defense contractors, certain financial services. These represent maybe 5% of the total AI market. For the other 95%, cloud APIs are better in every dimension except ideological purity. So let's address the "Silicon Valley is switching sides" narrative, because this is where the reporting gets most misleading. Yes, Chamath mentioned a portfolio company using Kimmy K2. Yes, Brian Chesky said Airbnb uses Qwen 3. But let's add some critical context. I went through Kamatha's portfolio on Social Capital's website, 23 companies listed. One has publicly moved workflows to Kimmy. That's 4%. And when he said it's, frankly, cheaper, he didn't mention whether it actually works as well, how much engineering time the migration cost, or whether they're keeping GPT-5 as a backup. This is a venture capitalist optimizing for the story that makes his portfolio company look innovative, not a rigorous comparison. Airbnb's use of Qwen 3 is for a narrow service agent application, basically structured customer service responses. According to sources familiar with Airbnb's AI infrastructure, reported by The Information, their core search, recommendations, and pricing algorithms still run on AWS Bedrock with Claude and GPT models. Using a Chinese model for one customer-facing chatbot doesn't mean switching sides, it means smart cost optimization for a low-stakes use case. Mira Murati's lab building on Qwen 3 is experimentation, not endorsement. Mira left OpenAI specifically to explore alternative approaches. That's what you do in research. It doesn't mean she thinks Qwen is better than GPT, it means she's exploring the design space. The Cursor rumor is just that, a rumor. I've used Cursor extensively. It feels exactly like GPT-5 with some fine-tuning. I reached out to Cursor's team for comment, and they declined to confirm which base models they use, standard for competitive reasons. But the performance characteristics strongly suggest GPT-5 or Claude, not a Chinese model. And Hugging Face downloads? Logan Kilpatrick, who used to run developer relations at OpenAI and now works at Google, tweeted about this: HF download stats are dominated by researchers and hobbyists. They're completely uncorrelated with production usage. He's right. I can download Qwen to experiment without ever deploying it in any product. SWIX actually analyzed this recently and found that for every 1,000 Hugging Face downloads, there are approximately 3 to 5 production deployments lasting more than 30 days. It's a vanity metric. So what's really happening? Here's my read, informed by conversations with ML engineers, enterprise AI buyers, and looking at actual deployment data rather than headlines. Chinese AI models are genuinely improving. The engineering is excellent. The cost optimization is smart. They're pushing Western companies to be more efficient and more competitive. That's healthy and good for everyone. But the idea that they're winning the race fundamentally misunderstands what winning means. According to Kleiner Perkins' 2025 State of AI report, 92% of Fortune 500 companies implementing AI use primarily Western models for production workloads. That number hasn't changed significantly despite a year of impressive Chinese model releases. When you talk to CIOs and CTOs, the reasons are consistent: trust, reliability, integration ecosystem, and support. I spoke with the CTO of a major healthcare company who summed it up perfectly. I can save $200,000 a year switching to Chinese models. But if that AI system makes a mistake that affects patient care, I'm looking at millions in liability and irreparable reputation damage. The risk-reward doesn't remotely pencil out. This is the chasm between impressive technology and trusted infrastructure. Benedict Evans, the tech analyst, calls it the difference between having good planes and having Boeing. China has good planes. America has Boeing, Airbus, and the entire ecosystem of maintenance, training, certification, and global partnerships that makes commercial aviation work. Let me make a prediction that goes against the current narrative. By the end of 2026, the gap between frontier closed models and the best open-source alternatives will be wider than it is today, not narrower. Here's why. Western labs are increasingly focused on capabilities that don't show up in benchmarks: long horizon planning, complex multi-stakeholder reasoning, deep domain expertise, and robust safety guarantees. These require massive training runs on proprietary data at scales that open-source projects can't match. According to leaked information about OpenAI's GPT-5 training, reported by The Information, they're using 30-50x more compute than GPT-4, with training runs lasting 6+ months. That's not something you can replicate with smart algorithms and efficient engineering, that's raw resource advantage. Anthropic's constitutional AI approach, which involves multiple rounds of RLHF with carefully designed value hierarchies, reportedly costs 3-5x more per parameter than standard training. But it produces models that align better with human values and make fewer catastrophic errors. That's the kind of investment that pays off in enterprise adoption, not benchmarks. Google's Gemini 3, based on information from internal sources speaking to TechCrunch, is being trained on multimodal data at a scale never before attempted, simultaneous learning across text, image, video, audio, and code with shared representations. That's not something open source can match because the data collection alone requires Google-scale infrastructure. Now, I could be wrong. Open source has surprised us before. But I've been tracking the actual capability gap, not the benchmark gap, and I see Western labs pulling away in the dimensions that matter most for real-world value. Here's what I think is the most important point, and it's something that gets lost in all the breathless coverage: this isn't actually a race with a finish line. AI development isn't the Olympics where someone crosses first and wins. It's infrastructure development, like electricity or telecommunications. What matters is building systems that billions of people can rely on for decades. China's approach of competing on price and democratization is valuable and pushes the industry forward. But America's approach of building trusted, reliable, deeply integrated AI infrastructure is playing a different game, one that's more important in the long run. When I talk to actual AI builders, not pundits or investors, but engineers shipping products, they're not switching to Chinese models en masse. They're experimenting, they're testing, and occasionally they're using them for specific cost-sensitive workloads. But the core infrastructure remains Western for clear, practical reasons. Clement DeLange, CEO of Hugging Face, the most open-source friendly company in AI, recently said something striking. Open-source models are critical for innovation and preventing monopolies. But even as the most pro-open-source company in the world, we run our internal production systems on OpenAI and Anthropic. That should tell you something. It tells me that even the people most ideologically committed to open source recognize that production reliability beats theoretical performance. So here's my advice: if you're trying to navigate this, don't get caught up in benchmark wars. Don't make technology decisions based on headlines. Test models yourself on your actual use cases. Measure reliability over weeks, not hours. Factor in the full costs: engineering time, debugging, maintenance, not just API prices. And recognize that the AI landscape is complex enough that multiple things can be true simultaneously. Chinese models are genuinely impressive and Western models maintain meaningful advantages. Open source is incredibly valuable and closed models serve critical needs. Competition is intensifying and the fundamental balance hasn't shifted. The real story isn't about who's winning or losing. It's about an industry maturing, getting more competitive, and ultimately delivering more value to users. Whether that value comes from San Francisco, Beijing, or anywhere else, as long as it's built responsibly and serves human needs, that's a future worth building. For now, that's my take on the Kimmy K2 situation and the broader AI landscape. I'll keep testing, keep learning, and keep bringing you the signal amid all the noise. Appreciate you being here, and until next time, peace.